In this video here, we're going to take a look at vector methods with projectiles. So projectile motion is motion in a vertical plane with constant acceleration. So in that case then, we can analyze this using the vector equations of motion. And when we're using vectors with projectile questions, you should consider I and j to be the unit vectors horizontally and vertically, unless we're told otherwise. So let's have a look then at an example demonstrating these concepts. So let's just take a look then at this one practice question here for vector methods with projectiles. So for this question, then what we're told here is I and j are unit vectors horizontally and vertically respectively. So that's fine, right? So we're then told that a particle P is projected from the origin with this given initial velocity here. So we've got 3i plus 10j meters per second. And we're then told that the particle moves freely under gravity. And we want to find two different things here. So for the first part, then part A, let's just write this down here to the right. What we want to find here is the position vector of P after 2 seconds. So what we're looking for then is basically the horizontal displacement, right? So for this question here, nice and straightforward, all we're going to do here is use suvat. Okay. So as we've mentioned then, all we're going to do here is use suvat. Now, normally for a projectiles question, you split the motion up right into horizontal components and vertical components. But for this question here, when we're working with vector methods with projectiles, we don't need to do this, right? Because just consider the initial velocity here, for example. We've got the horizontal component here, 3i, and we also have the vertical component as well of 10j here. So we kind of consider it as just one part rather than splitting it into both the horizontal and the vertical component. Okay. So if we're going to use suvat here, then what do we have? Let's just list what we have here to hand. So for the displacement S here, well, that's what we want to find, right? So S here, this would be a vector. So let's just denote that as a vector, right? And that's what we're looking to find. So let's put a question mark here. That's what we're looking to find. So for you here, again, this will be a vector. So for you then, that's what we're given here. So that's going to be 3i plus 10j meters per second. Let's put 3i plus 10j, like so. We don't have anything for v here, so we'll just leave that. So for a here, the acceleration, this will be, again, a vector. And for the acceleration here, right, so acceleration is due to gravity, so it acts downwards. So we'll take this as negative here. So this is minus 9.8 j here. Okay, so minus 9.8 j there. Okay, like so. And then finally here for the time t. So t is just a scalar, right? So we don't need to denote that as a vector. And t here then is 2, right? It's 2 seconds. So t equals 2 here. Okay. So based on the information that we have to hand here, we're going to use then S equals ut plus a half at squared. Okay. So in that case then, S is what we're looking to find, right? So S is equal. So we have ut, so u is 3i plus 10j, times by t, which is 2. So I get 2 lots of 3i plus 10j here. So 2 lots of 3i plus 10j. Okay. Obviously, this would be a vector as well. I should also denote it here for this equation, but I'm just going to be a little bit lazy here. But you should do it really. So S then is equal to 2 lots of 3i plus 10j. So that's ut. We then have a half at squared. So we've got a half times by a, which is minus 9.8 j here. Minus 9.8 j here. And then we times this by t squared. So t is equal to 2. We times it by 2 squared, which is 4. Okay, like so. So let's just simplify here then. What do we get? So S is equal to, so I get 6i plus 20j. So 6i plus 20j. Like so. I've got half times by 4, so that's 2. So 2 times minus 9.8j here, so that gives me minus 19.6, right? So minus 19 0.6j there. Okay, like so. And then if we simplify this here, what I get then is 6i. We can't do anything with that, right? We get 6i. And we've got 20j minus 19.6j. So if we simplify that here, I get plus 0.4j there. Okay, like so. And there we have it. So what this gives us here then is the position vector of the particle P after 2 seconds. So that's the solution to part A there. And now for part B then, let's do that over to the left-hand side here. We want to find the speed of the particle P here after 2 seconds. So don't forget then that speed is equal to the magnitude, in this case, of the velocity vector. Okay, so it's the magnitude of the velocity vector. So in that case then, again, just using suvat here, well, what we're going to use, or what we need to use here, so we're going to use them, is v equals u plus at here. Okay, so v is a velocity vector, same for u, and same for a here. So in that case, then what do we have here? So v, that's what we're looking to find, right? Because we need to find the magnitude of that. We don't know what v is. U is my initial velocity, which we were given in the question here. That's 3i plus 10j. Then we've got at here. So a is just minus 9.8j again, and t again is 2 here. Okay, so nice and straightforward then. We get plus, so it's going to be t, which is 2, times by a, which is minus 9.8j here. Like so. If we simplify this here, then what do we get? So I'm going to get 3i here. I can't actually do anything with that, right? So I'm going to get 3i again here. Can't do anything with that. I've got 10j plus 2 lots of minus 9.8j. So that's going to be minus 19.6j. So 10 minus 19.6, that's going to give me minus 9.6j. Minus 9.6j there, like so. So this here then is my velocity vector. But don't forget then, if we want the speed here, we need the magnitude of this velocity vector here. So in that case then, so for the speed here, as we've already highlighted here, right, that's the magnitude of the velocity vector. And don't forget then for the magnitude here, that's simply an application of Pythagoras. So this is the square root here. We take the square root then of 3 squared plus minus 9.6 squared here. So 3 squared plus minus 9.6 squared. Okay, like so there. So just put this into your calculator here, and hopefully you do this correctly. You'll get the square root of 101.16 here. Okay. And then if we evaluate this here, what would we get? Well, that would be 10.1 there if we do that to 3 significant figures here. So we get 10.1 meters per second there, right? So its speed is just meters per second, like so. And there we have it. So what this is here then, I should say, is the speed of the particle P after 2 seconds. So this here then, this is the solution to part B. And this here then is the solution to part A. So let me just highlight these here. Like so, just so you can kind of see them a little bit more clearly here. That's the solution to part A. And this here then is the solution to part B. Okay. So there we have it. So for this video here, we are just going to look at the one question here. I don't think you need too many questions really for vector methods with projectiles. We have covered projectiles in quite a bit of detail, right? So just go back to the projectiles chapter if you do want a little bit of extra practice here for projectiles. Obviously, for vector methods, it is pretty much the same, just obviously adapting it to vector methods. So pretty straightforward, I do think really, and hopefully you do feel the same way. But there we have it. So that gives us the solution to the one practice question for this video here. And that brings us to the end then of this video here on vector methods with projectiles.